Engineering degrees and technical fields are some of the most in-demand choices for graduates today. But to truly succeed, every engineer needs to understand some key mechanical and physical principles. So in this video, let's break down some of the foundational ones, starting with clearances and tolerances. When you're designing precise or complex parts, keeping track of clearances and tolerances is crucial. Tolerance refers to how much a dimension can vary and still be acceptable. For example, if you're ordering bolts or designing custom components, you need to know how precise the parts need to be, and whether your manufacturing method can achieve that precision. Every machine has a tolerance limit. If your design requires tighter tolerance than the machine can handle, you'll have to use a more accurate tool or method. Now, clearance is the actual space you leave between parts to prevent issues like friction or collision. If a part needs 2 centimeters of space, and you're okay with plus or minus 0.1 centimeters of variation, that 0.1 is your tolerance. Next up, forces, pressure, and friction. A force is simply mass multiplied by acceleration. Forces are everywhere in our daily lives, and two specific types, friction and pressure, come up a lot in engineering. Friction is what lets things grip, slide, or resist motion. It acts between two surfaces in contact, and can vary depending on surface texture, speed, and direction. There are two main types, static, not moving, and kinetic, moving. Pressure, on the other hand, is the amount of force applied over a specific area. It's typically measured in units like SI, pounds per square inch. Think of it like this. Step on snow with flat shoes and you don't sink, but wear heels, and you go right in. Same force, smaller area equals higher pressure. Let's move on to velocity and acceleration. Velocity is the speed of something in a specific direction, making it a vector, since it includes both magnitude and direction. Acceleration is the rate at which velocity changes over time. It can be positive, speeding up, or negative, slowing down, which is also called deceleration. Mastering velocity and acceleration is essential, because every other concept, from energy to force, builds on this foundation. Now let's talk about work and energy. Work happens when a force moves an object over a distance. If there's no movement, no work is done, even if a force is applied. Energy is simply the ability to do work. A good example, when you're sitting in a car at the top of a roller coaster, you're full of potential energy. As you fall, gravity does the work, turning that potential into kinetic energy. Think of energy as the currency that lets you do work. Your body, your car, even machines all need energy to function. And just like money, you can spend energy in different ways depending on what kind of work needs to be done. Last but not least, stress and strain, especially important in material science. Stress is the amount of force applied per unit area. Strain is the change in shape or deformation that occurs because of that stress. If you're a student, you could think of it like this. Stress is how many exams you've got, and strain is how much your sleep schedule suffers because of them. Every material has a maximum stress and strain it can handle. Go beyond those limits, and you risk permanent damage, or total failure, of the part. All of these concepts, clearances, forces, velocity, energy, stress, they are deeply rooted in physics and math. As an engineer, you might not always calculate them by hand. Most CAD software and simulation tools handle the heavy lifting. But even if the computer does the math, you still need to understand what's happening behind the scenes.